Hello everyone. Today we're going to go over some more of the basics. So that's going to be evaluating expressions, making variables, and talking a little bit about state. And again, I'm Patrick Violet with Issaquah Robotics Society. Okay, so let's get started. So how are we going to write programs? Well, what's going to happen is you're going to have in your programs a bunch of what are called statements. And a statement is just a line of code that provides one or more commands to the computer. Simple as that. And usually statements can be evaluated into a single value, and they always end with a semicolon. So let's see how this is going to work. Alright, start with a simple statement. How about 1 plus 1? Alright, well, it is a statement because 1 plus 1 can be evaluated to 2, and there's a semicolon at the end. Cool. So what's going to happen when the computer runs this is it's going to say 1 plus 1 is a statement, evaluate 1 plus 1 to be 2, and then be done. Yay! Also, the computer can also process multiple commands in a single statement. So we've got nested evaluation here. Java will follow the order of operations, and so if we have something like this, 1 plus 1, the quantity times 4, it's going to evaluate 1 plus 1 first to make this 2 times 4, and then evaluate 2 times 4 to be 8. So Java can also handle multiple evaluations in a single statement. Okay, so that's the basic building block of our code. So when we make a program, we'll just have a bunch of statements that run. So for example, we've got 1 plus 1, then we'll do some more math, and so let's walk through this. Well, 1 plus 1 evaluates to be 2. Cool, so that's done. 3 minus 5 is going to be the next line, and that's going to evaluate to be negative 2. Then we're going to add 6, so this line should evaluate to be 4. And then the last one, 1 times 5, well that's going to be 5. And so there we are. Alright. And so that brings us to something called state. Okay? So state is a specific configuration of ones and zeros in the computer, and it's used to store information. Okay? And now, as a computer program runs, the state of the computer is going to change because there's going to be different information that needs to be stored at specific times. So, for example, in the previous slide, each line had a different state. There was a different configuration of ones and zeros in the computer in each line. Alright. Now, state is lost from line to line. So if we go back to this example, we have 1 plus 1, then 3 minus 5 plus 6, then 1 times 5. So every time it's going to walk through, evaluate the expression. So the first one's going to evaluate to be 2, then evaluate to be 4, then evaluate to be 5. But you can't actually access the previous line. So in line 2, that's 3 minus 5 plus 6 here. From here, we can't say like the previous answer plus 2. That doesn't work. And so what we have is, to solve that problem, is this notion of a variable, which is a state store. It's a fundamental way of storing state or information about the program as it's running in computer languages. Okay? Now variables are kind of interesting because they can only store one value at a time. And in Java, they will store a certain type of value. So it might store an integer or a character or something like that. We'll get to more of that later. And so here's kind of how you work with a variable. So variables have to be declared or created before you can use them. And to do that, they will have a type and an identifier. Both of those things are required. So here's an example. If we have int, this is a special kind of type that is, you guessed it, an integer. Okay, so there's our type, check. And now here's the people at the carnival. That is going to be the name of our variable or the identifier. And then it's going to end with a semicolon. Kind of something to remember. Alright, so what does this actually do when we run it? Well, it's going to create a place to store state. This little box here is kind of representing that. And it's going to store an int, as we figured out from here, and the name of this box, if we ever want to access the value inside of it, is going to be people at carnival, or the identifier that we declared it as. So there we go. There's that. Now we have a declared variable we can work with. Alright, so now how do you store values in variables? Well, you use something called the assignment operator to do that. It looks suspiciously like an equal sign, and we'll talk a little bit later why it's suspicious. But here's how you use it. So what we do is, here this is going to declare a variable named sum. This is going to be of an integer data type. And now, here's the important part that we care about right now. Okay, so we've made this place to store integers, and it's named sum. So what the assignment operator is going to do is it's going to evaluate the right side of it. So in this case, it's just going to evaluate to be 1, and then store that value into the variable, and this must be a variable. We'll store that value into a variable on the left of the operator. So in this case, this line is running, and now 1 is going to be stored into the sum variable. So now what we've done is we've stored the state, or the information of 1, into this place, and now we can access it later. So how do you use them? Well, I might have something like this. Alright, so walk through this line by line. Int sum declares a variable of type integer, so we're going to store integers in this box, and if we ever want to access it, all we have to do is use the identifier sum. Alright, now, next line. All this is going to evaluate, right, because we've got an assignment operator, so the right side is going to evaluate, and then that value is going to be stored inside of the variable on the left of the assignment operator. Alright, so let's evaluate the right side of it. Well, 1 plus 7 is 8, plus another 6. Looks like it's going to be 14, plus another 6 will be 20. Alright, so 20 is evaluated over here, and now so 20 should be stored in the sum variable. Cool. So we evaluated that. Now let's declare another variable. Looks like name is going to be average. That's the identifier we'll use to access it, and then it will store ints. So here we go. So this line of code made this place to store integer state. Now, next line. We've got a note here. Variables evaluate to be their stored value. So if you want to get the value inside of the sum variable, all you have to do is say sum, and that's the identifier. So here we are. Well, sum is going to evaluate in quotes here because it's not actually technically evaluating, but it's going to evaluate to be 20 because that's what's stored inside of it. Then 20 divided by 4 is going to be 5, and then that evaluated the right side of the assignment operator, and now that value is going to be stored in the variable average. So here we go. Average is now 5. Cool, and we're done. Alright, so now, one more thing. Initialization of a variable is assigning a value to a variable in the same line of code that it's declared. Okay, so we had been declaring variables like this, int x, and then saying x equals 6, and that stores the value of 6 into x. Well, what Java let us do is actually do that in a single line. And that's good because now we don't ever have variables kind of floating around without any value inside of them. So, when we run this line of code, int x equals 6, first, it's going to make the variable x that stores integers, and then it's going to evaluate the right side of the operator and then store it into the variable that we just made. Cool. Now, here is a fundamental difference that exists between variables in math and variables in computer science. So here's in math. Algebra, a variable will represent many values. So if I say x, x is all numbers. Okay? And what we'll do is we'll assume that both sides of an equal sign have to be true. Okay? So if this side is 24 and we say that 5x plus 4 is equal to 24, then we'll assume that this is a true statement. And therefore, x is going to be constrained by the equal sign to only be values that make this true. Okay? So, as we solve this equation, subtracting 4 from both sides, we get 5x equals 20, and then x equals 4. Okay? And so now, what we can do is substitute x in at any line and still get a true statement. So if x is 4, 4 equals 4. If x is 4, then 5 times 4 is 20, which is the same as 20. And if 5 times 4 plus 4 is 24, then yes, 24 is 24. So what we can do is walk up and substitute x in and still get a true statement. Okay, because this equal sign assumes that both sides are equal to each other. But what's going to happen when we do computer scientist stuff is we're going to increment the variable sometimes. And we'll get some kind of interesting things. Alright, so what an increment is to increase the value of a variable by 1. So let's say we have a variable, int x equals 1. We learned that we can initialize a variable in the same line we declare it, and so that's what we did here. Alright, and then have these things. Alright, so here's my box, x, and it's going to store ints. Alright, so now it's going to be initialized to 1. So walking through this code, we'll jump to the next line. 1 plus 1, well that makes 2, and so 2 is going to get stored in x. Okay, now 2 plus 1, we're going to increment the value of x by 1, so we'll have 2 plus 1, and then that value is going to be stored in x, so now 2 plus 1 is 3, so x is now 3. After this line, incremented by 1 again, 3 plus 1, that evaluates to be 4, and then 4 gets stored into x, so now x is 4. And now here's the interesting thing that we can do. Now we can say x plus 1. Well, what's x going to be here? 4. Alright, so now we have 4 plus 1 evaluates to be 5, and so now we've incremented the value of x by 1. Now, ask yourself this question. Can we plug in the value of 5 at any line like we could in algebra and get a true statement? Obviously not, right? We plug in 5 here. 5 equals 2 plus 1? No, 5 does not equal 3. That doesn't work. Right? So that's mathematically, technically, algebraically incorrect, but doing things like this is computationally encouraged, and this is the idea of state coming into play. The values of our variables are changing as our code, as our program is running. Okay? So here we go. So that's just something important to keep in mind, and that is why the assignment operator is suspiciously looking like an equal sign, but is not actually an equal sign. So something that's very important to keep in mind is that state is changing with our variables. Okay, so that's it. But I highly encourage you to do these exercises. Okay, so I've got two kinds. There's find and do. So here are the find ones. I want you to find rules and conventions for naming variables in Java, and then think about why those rules would be necessary with the knowledge that you have of how code is run from a high-level language. What processes take place in order to run code that we write in English? So that's something to keep in mind. And then B, when might you have a perfectly valid identifier or name for a variable, and then when might that be made invalid? I'll post answers to these later. But okay, and then 2, an int is a primitive data type, right? We said that to declare variables we need a type of data. Well, as it turns out, Java has more than one data type. So for primitives, there are 7 others. And so find a list of those that you can access because we'll be using them later. Alright, now exercises. Here's some code that I want you to write. I want you to declare a non-integer decimal variable, so you might have to look at that list you found earlier, and then write a code that finds the actual average of 2, 3, and 8, and then stores it into the declared variable. And then finally, I want you to make 3 variables, a, b, and c, and then store their product into a 4th variable, and you can choose the values of a, b, and c. So that's it for today. Thank you guys. I hope you learned something, and do your exercises. I will see you in the next video.